In October 2017, something mysterious entered our solar system. It is a highly elongated, reddish, cigar-shaped object, roughly 100,000 meters long. It wasn't a comet, it wasn't an asteroid. It came from interstellar space. Scientists would later name it Oumuamua. But its discovery started with a strange signal. Astronomer Robert Warwick noticed something unusual in data from the Pan-STARRS telescope in Hawaii. At first, it looked like a normal asteroid. But when scientists tracked its path, the truth was shocking. This object wasn't orbiting the sun. It was passing through our solar system from another star. Then things got even stranger. As Oumuamua left the solar system, it accelerated. No comet tail, no gas, nothing pushing it. That's when Harvard astrophysicist Avi Loeb proposed a wild idea. What if Oumuamua wasn't natural at all? Imagine if we didn't just see Oumuamua. What if it saw us first? Because here's the truth. We didn't detect Oumuamua when it entered the solar system. We only saw it after it had already swung around the sun and was on its way out. By the time astronomers like Robert Warwick spotted it using the Pan-STARRS, Oumuamua had already made its closest approach to the sun. It had already passed near Earth, and we had missed our only chance to study it up close. Think about that. A mysterious object from another star system entered our cosmic neighborhood, and we barely noticed. At first glance, Oumuamua didn't make sense. Most asteroids are chunky, and most comets are icy snowballs. But this thing? It was either a long, thin cigar or a flat pancake-like disc, and either way, it was tumbling wildly through space. Scientists analyzed how it reflected sunlight. The brightness changed dramatically, suggesting an extreme shape, something we had never seen before. Even more unusual, its surface was reddish, similar to objects exposed to cosmic radiation for millions of years, meaning Oumuamua had been traveling through interstellar space for a very long time. Then came the detail that changed everything. As Oumuamua left the sun, not because of gravity, but because of something pushing it. Normally, comets accelerate like this when ice evaporates, creating a visible tail of gas and dust. But Oumuamua, no tail, no visible outgassing, nothing. According to observations from NASA, the acceleration was small but very real and completely unexplained. So scientists asked, what could push an object through space without leaving a trace? Avi Loeb, a Harvard astrophysicist with a controversial idea, what if Oumuamua wasn't powered by gas at all? What if it was being pushed by sunlight, radiation pressure, photons from the sun hitting its surface like wind pushing a sail? For that to work, Oumuamua would need to be extremely thin, incredibly wide, and lightweight. In other words, a light sail, a technology humans are already experimenting with. Projects like Breakthrough Starshot aim to send tiny probes to other stars using light. So Avi Loeb asked the question no one else wanted to. What if this wasn't just physics? What if it was engineering? Let's take it further. What if Oumuamua wasn't just debris, but intentional? A probe, a scout, a messenger. Imagine a civilization millions of years more advanced than us. Would they send bulky spacecraft or thin, efficient, nearly invisible probes that drift silently between stars? Oumuamua had no engines, no signals we could detect, and no obvious structure. But what if that's the point? A probe designed to avoid detection, survived for millions of years, and gathered data quietly. By the time we noticed it, it was already leaving. Mission complete. Not everyone agrees with the alien hypothesis. Many scientists argue there are natural explanations. One leading idea is that Oumuamua could be made of hydrogen ice. As it warmed near the sun, hydrogen gas would escape, producing thrust without a visible tail. Another theory is that it could be made of nitrogen ice, similar to the surface of Pluto, chunks of frozen nitrogen ejected from distant planets drifting through space. These ideas explain the acceleration, but they come with problems. Hydrogen ice should evaporate quickly in interstellar space, and nitrogen fragments that large should be extremely rare. So the mystery remains. Here's the part most people miss. Oumuamua might not be unique. In 2019, another interstellar object was discovered, 2I Borisov, but unlike Oumuamua, it looked like a normal comet, with a tail, with gas, with behavior we understood. Which makes Oumuamua even stranger. If most interstellar objects are like Borisov, then why is Oumuamua so different? Unless it's not the same kind of object at all. Now imagine this. What if thousands of objects like Oumuamua pass through our solar system every year, and we just don't see them? Small, dark, fast, invisible to our current technology? What if we're surrounded by interstellar visitors right now, and what if some of them aren't natural? Scientists aren't ignoring this mystery. New telescopes are being built, more powerful, more precise. The Vera C. Rubin Observatory will scan the sky like never before. Its mission is to detect faint, fast-moving objects, catch them earlier, and study them longer. The next Oumuamua we might see coming, and next time we might be ready. Imagine launching a mission, a spacecraft designed to intercept the next interstellar visitor, to photograph it up close, analyze its surface, and search for signs of technology. To answer the question once and for all, natural or artificial, because right now, we don't know. Oumuamua is gone, drifting back into the darkness between stars. We may never see it again. We may never know what it was, but its visit changed something. It showed us that the universe is not isolated. Objects travel between stars, and maybe, just maybe, so do civilizations. So the next time you look up at the night sky, ask yourself, what if something has already been here, watching, waiting, and leaving without a trace? What do you think Oumuamua really was? A cosmic accident, or our first contact with something not from Earth?